Right. Good morning, everyone. Welcome to the class. We have been discussing sequential circuits. In that we have seen what is the difference between level triggered and edge triggered. Once again, I'm confirming that level triggered is a latch, edge triggered is a flip flop. Using level triggered latches, we have been constructing edge triggered flip flop. The construction also we have seen how to construct edge triggered flip flop using level triggered latches. And in that we have seen that positive edge triggered flip flop and negative edge triggered flip flop. If it is sensing to the input at positive edges of clock, then it is called positive edge triggered. If it is sensing input at negative edges of clock, then we say it is negative edge triggered flip flop. Negative edge triggered flip flop. In this, we try to understand how we have constructed a negative edge triggered flip flop. I think some people were asking some doubts. I'm going to give you clarity about all those doubts. So please wait, have some patience. Let us understand these concepts in depth, which can help us in understanding next level of questions in competitive exams. Not like just counters. We have been getting very good questions if you are observing recent years questions. And one more suggestion here, try to solve all the classroom practice questions. I'm going to solve all the questions, but my intention is you have to try on your own. You have to think in a right way, because you have to understand the question given in the exam and you must be in a position to answer given question. That is the reason I'm suggesting you to try first. I'm there to help you. I will solve each and every difficult question. So wherever you are thinking that not discussed, like a combination circuit classroom practice questions, I will discuss. But before I discuss the questions, I'm expecting you to try on your own, because you have to understand the question correctly. Then if I solve, then you may be seeing that, oh, I was wrong in this way. You need to think. That's what you need to correct our mistakes. We need to correct our mistakes before going to final exam. Instead of correcting after completing exam, let us correct our mistakes before going to final exam itself. That's what my intention. Please wait. Please understand concepts correctly. Yeah, Prithvi Raja, I will help you in that also. Hold on. So, don't be late to the class. Try to be logging in 5 minutes before itself. So just 2 hour session we have, and you made us to take only 2 hours. Okay, not a problem. So let us utilize this 2 hours effectively on discussion. Yes. So what we have been saying is here, while drawing inputs itself, I mentioned don't change your D input while control is changing from 0 to 1 or 1 to 0. What I mentioned here, don't change your D input while control is changing from 1 to 0 or 0 to 1. Why? What happens if I change? What we discussed here, so this construction is becoming negative edge triggered flip flop. At this negative edge, we are observing what is it here? Logic 1 enable latch is getting disabled. Logic 0 enable latch is getting enabled. Or master is getting disabled. Slave is getting enabled. The edge where it is sensing to the input, the point if you are observing correctly, the construction is resulting negative edge triggered means the construction is resulting negative edge triggered. So what can we say here? So this negative edge triggered or at this negative edge, what is happening exactly with respect to latches is logic 1 enable latch is getting disabled because controller clock is changing from 1 to 0. If it is 1, it is enabled. If it is changing from 1 to 0, this is getting disabled. Obviously, the other one is getting enabled. The point where the circuit is responding to the input or sensing to the inputs is master is getting disabled, slave is getting enabled. The point where master is getting disabled, slave is getting enabled. There, the circuit is responding to the inputs. Circuit is responding to the inputs, or the flip-flop is responding to the inputs. So with respect to master-slave construction, what can we say here? The point where this flip-flop is sensing to the inputs is a master disable point, a slave enable point. As master is logic 1 enable, slave is logic 0 enable, wherever control is changing from 1 to 0, there it is sensing to the inputs. There it is sensing to the inputs. So it is a negative edge triggered flip-flop because master is logic 1 enable, slave is logic 0 enable. If I interchange, if master is logic 0 enable, slave is logic 1 enable, then obviously it becomes a positive edge. Master is logic 0 enable, slave is logic 1 enable. Master disable point when it is changing from 0 to 1. So master disable point, slave enable point, there it can sense the inputs. There it can sense the inputs. I hope you are following correctly. So what we have been discussing is a master slave construction, which is a resulting edge triggered. This is one way of construction flip-flop. This is not the only way. We have a n number of ways to implement a flip-flop, which is a edge triggered. Most of you might have studied as a difference. Latch is level triggered, flip-flop is edge triggered. But while coming to flip-flop, once again, what we say that latch with clock is a flip-flop. Right? Generally, you might have studied these things, even though you have done coaching, sir. There is a mistake you are doing. So please understand this correctly. Latch is latch itself. How can it become a flip-flop? How can it become flip-flop? Latch is latch itself. When it is latch, it is responding to inputs depending on level of clock or level of control. Control can be a clock, clock can be a control. Is there any rules for control? No. When there is no rules for controls, control signal, then how can you say that latch with clock is a flip-flop? How clock is different from control? Control can be a clock. How it can be different? So if the control signal has been changing to clock, how the behavior of latch is changing? No, it cannot be changed. Latch is always level triggered. It keeps on sensing to the inputs depending on level of the clock or level of the control. But flip-flop is responding to the inputs or sensing to the input at respective edges only. It may be either positive edge triggered flip-flop, positive edges, negative edge triggered flip-flop at negative edges of clock. Depending on construction, it may be responding to the input only one type of edges only. It may be either positive edge triggered or negative edge triggered. This is what we have learned earlier also. We have been discussing. Yes, sir. Right. So Neeli Teja has a doubt why it is master, why it is slave. So this one is following this one, right? This one is following this one, right? So it is driving, it is following. So understand that in that way. Master and slave. Master and slave. Master is driving slave, or slave is following this one, or this latch is following this one, or this output, right? Then obviously it is following this means it is slave only. Neeli Teja, are understanding? One latch is following other latch output. Am I right? Are you there, Neeli Teja? Why it is called master and slave, you are asking. If you are observing, this is producing its output, but this is following that output. So simple thing is, whoever is following is slave. Whoever is following slave, whoever is driving is a master, right? Yes. So in this, if you are observing at negative edges of clock, it is sensing to the inputs. At this negative edge, what we are observing, master is getting disabled, slave is getting enabled. Slave is getting enabled. Now, at this point of time, if you are observing, at this point of time, master is getting disabled, master output is constant. At this point of time, master is getting disabled, master output is constant. Understand correctly? At this point of time, master is getting disabled, master output is constant, slave is following master output. Am I right? At this point of time, master is getting disabled. Even though master inputs are changing, master output is not changing with respect to its input changes. So master is getting disabled, master output is constant, slave is getting enabled, slave is following master output. Slave is following master output. Correct? At this point of time, once again I'm analyzing, at this point of time, master is getting disabled, master output is constant, slave is getting enabled, slave is following master output. Yes, at this point of time, exactly at this point of time, slave is getting enabled. As slave input is observed, it is logic 0, slave output is becoming 0. Understand point correctly? In a sequence. At this point of time, what is happening here? Slave is getting enabled. As slave is observing, its input is 0, slave output is becoming 0. At this point of time, it is getting enabled. At that point of time, input is 0. At that point of time itself, output is becoming 0. Is it possible? No, because it is having its own delay. The circuit is having its own delay. It is enabled at this point of time exactly. At that point of time, input is 0. At that point of time only we are saying that output is 0. It's not possible. To change its output, it is taking some time. It is taking some time. So the time required to change the output, from clock edge occurrence, because as it is negative edge triggered flip-flop, at negative edge, if there are any changes in the outputs of flip-flop, those changes are occurring not immediately. Because so in this construction itself, we can understand at that point of time it is getting enabled, observing input is 0, output has to become 0. Output we have shown in 0 time, it is changing from 1 to 0. Impossible. It is getting enabled, then according to its input, it is changing its output. So it is having a delay. This delay is called a flip-flop delay. And what is flip-flop delay? The time required to change the flip-flop output from inputs changed will be wrong. It is not from input to output change. What is it here? From the clock edge occurrence, the point where it is should be considered from the clock edge occurrence to Q output variation. So it is named as a TCK to Q, clock to Q, TCK to clock to Q delay. What is it here? T flip flop, TCK to Q. Or what you can say here, from the clock edge occurrence, it is taking some time to change the output. It is not from D input to output. So at that edge, it is getting enabled. At that edge, it started changing. For changing, it is taking time. So the time is called flip-flop delay or clock to Q delay. The reason for saying that clock to Q delay is from the clock edge occurrence, Q output variation. From the clock edge occurrence, Q output variation. So it is named as clock to Q delay. Clock to Q delay, CK to Q or clock to Q delay. From the clock edge occurrence, flip-flop output is changing. That change cannot happen in 0 time. The change is occurring after some delay. The delay required to change the flip-flop output is called flip-flop delay or clock to Q delay. Reason behind saying that clock to Q delay is clock edge occurrence to Q output variation. Flip-flop delay, what are the flip-flop we are mentioning? In that flip-flop delay is not from D to Q. It is from clock edge to Q or clock to Q. Understand correctly? The flip-flop delay is not from D input to Q output. Flip-flop delay is from clock edge occurrence to Q output variation. So, unless or unlike logic gates or logic circuits we have discussed till now. What is the delay? The time required to change the output from the point inputs changed. It is not input. Yes, it is also one type of input, but specifically let us say that it is from clock edge occurrence to Q output variation. Delay is clock to Q delay. It is not from D to Q. But in the latch, there is a possibility for D to Q. Latch D to Q, because D variations are propagated to Q variations when it is enabled. That is D to Q delay will be there in the latch. But in flip-flop, we have clock to Q delay or clock edge occurrence to Q output delay. Try to understand correctly. Each and every point is important. In a latch, we have a delay, input to Q output or input to output. But in flip-flop, we have a clock edge occurrence to Q output variation, which is a clock to Q delay, I hope you are understanding. So what is it here? It is TFF or TCK to Q, T clock to Q delay, T clock to Q delay. So Flip-flop delay is from clock edge occurrence to Q output variation. Yes. And this one point, we have two more points to be discussed. So let us understand what is this two more points. So while drawing that input itself, have given a condition. Don't change your input while control is changing from 0 to 1 or 1 to 0. Once again, what is it here? I mentioned don't change your D input while control is changing from 0 to 1 or 1 to 0. Why? What happens if I change? What happens if I change? Let us see. So I'm going to modify this. Let us see the modifications. So whatever the doubt you have, the same doubt I've been getting, let me give clarity about that. So I have given a condition, don't change your input while control is changing from 0 to 1 or 1 to 0. Why I should not change? What happens if I change? Let us see here. So instead of like this, the input, if it is like, don't modify if you have drawn. So let me modify here. So if it is like this, what do you mean by this? Exactly at the edge, it is changing. Exactly at the edge, it is changing. Am I right? So I am changing my input exactly at the edge. Let us understand what happens. So at this clock edge occurrence, exactly at the edge, it is changing. What is that? The input is changing from 1 to 0. So let me draw that now latch output. What will be latch output? In this relation enable, it is following its input. It is following its input. It is following its input. What will be there? Till this point, it is saying at that point of time, understand correctly. What is the confusions you will be getting or what confusions will be there? Let us understand here. At that edge, it is changing from 1 to 0. At that time, it is changing from 1 to 0. Till that point, latch, what is that? Master latch is enabled following its input. Yes, following. At that point of time, it is getting disabled. What is it here? Master is getting disabled at this point of time. Am I right? When control is changing from 1 to 0, master is getting disabled. Master is getting disabled. But what is happening here? Its input is also changing from 1 to 0 exactly at the edge. But what happens here? Master is getting disabled. Master is getting disabled. Master input is changing from 1 to 0. Then it cannot capture this change before it is getting disabled. So what happens here? After this point, it is going to be logic 1 only. At that point of time, as it is getting enabled again back to 0. Again back to 0. So this will be the waveform. This will be the waveform. Sorry. Anyone has any questions? Why it is happening like this, sir? It is not able to propagate this change before it is getting disabled. At this point of time, it is getting disabled. At this point of time, it is getting disabled, correct? So getting disabled, its input is changing from 1 to 0. Before it is getting disabled, it cannot propagate the change to master output. It is not able to propagate the changes to master output. That is the problem we are facing in this. Try to understand this here. At this point of time, at this clock edge occurrence, my input is changing. But at that point of time itself, master is getting disabled. That is the reason what is happening here. It is not able to propagate this change. Whatever the input change is there, that change is not propagated by master before it is getting disabled. That is the reason master output is not becoming 0. Master output is continuing in 1. At this point of time, again when it is getting disabled, it is following again input. But at this clock edge occurs, what is the input we are expecting to capture? A logic 0. So when it is 1 here, obviously slave also, what will be slave? At this point of time, slave is getting enabled, slave is following master output. And again after this also it is getting disabled, it continues. What is the flip-flop output at this clock edge occurrence now? Logic 1. I hope you are able to write these waveforms correctly. Simply enable, disable, that's it. So till this point it was enabled. At this point of time it is getting disabled. Which one? Master. I'm drawing about master. At this point of time it is getting disabled. Even though inputs are changing, that inputs are not captured by the inputs are changes are not captured by master before it is getting disabled. That is the reason the master will continue in logic 1 itself, because it is not able to see logic 0, because the change is occurring exactly at the edge. That change is not propagated by master. So at this point of time, it continues in 1. It continues in 1. Then what happened here? After this point, as slave is getting enabled, slave is following master output. Once again, master is getting enabled, slave is disabled, slave is following its own cue. Yes. So at this point of time, the flip-flop is capturing a logic 1. No, I want to capture a logic 0, because I'm giving a logic 0 here, but flip-flop is not capturing logic 0. Why it is not able to capture this logic 0? The input is changing exactly at the edge, is not accepted by flip-flop. Then what you are expecting? If you are expecting a logic 0 should be captured at this edge, the logic 0 must be stabilized sometime before clock edge occurrence only. Sometime before clock edge occurrence. Try to understand this. So it must be available sometime before clock edge occurrence only. Then only the master can propagate the change, then slave will be following. So how much time it is expected to be available? How much time? The time required, minimum time required, is called setup time. Most of you might have heard this word, but may not be knowing what is the reason for setup. What is it here? Setup time. What is setup time? The minimum time required inputs to be stable before occurrence of the clock edge. If you are expecting a 0, that 0 must be stabilized sometime before only. The minimum time required is called setup time. So this is a property of a flip-flop. What is it here? If you are expecting a 0 should be captured by flip-flop at a clock edge occurrence, 0 must be stabilized sometime before or setup time before only. If you are expecting a logic 1 should be captured, then the logic 1 must be available setup time before clock edge occurrence. It can be earlier than that, but in this window, in the setup window, you should not change your input. Then if you are changing input, change in input will not be captured by flip-flop. That is the problem we need to understand from this. So what is it here? So without the problem, it has to work. If you are expecting, then obviously what we expect here, the input must be having some setup time, or it must be stable sometime before clock edge occurrence only. That sometime or minimum time required is called setup time. Is called setup time. So simple definition is for a flip-flop, inputs must be stable sometime before clock edge occurrence only. That minimum time required is called setup time. Yes, it is meeting setup time. So then exactly at the edge, again it may be changing. If it is changing like this, again it's a problem. Again it's a problem. So it is meeting setup requirement. It is expected to be a 0, but again at the edge, again it is changing from 0 to 1. What is this problem is, we can understand soon clearly. So what is expected here? That 0 must be available for some more duration after clock edge occurrence also. The minimum time required after clock edge occurrence is called, what is it? Hold time. Hold that input for some more duration after clock edge occurrence also. Then only flip-flop can capture that expected once again. So it is meeting setup requirement, but it may be changing exactly at the edge again. No, that must be available for some more duration after clock edge occurrence. That means this is called setup hold window. In this duration, you should not change your input. What is it here? Sometime before clock edge occurrence, sometime after clock edge occurrence. This window is called setup hold window. In the setup hold window, you should not change your input. What is the reason for this hold? You will understand later clearly. Clearly, you will understand when you are analyzing flip-flop to flip-flop communication with respect to clock and with respect to input variations. I'm going to talk about that later. Until that, hold on. At this moment, what we can say here? So the input must be stable sometime before clock edge occurrence. That is called setup time. The input must be stable after clock edge occurrence. Also, sometime it must be stable. That requirement is called a hold time. Finally, 3 words we are understanding. One is flip-flop delay or clock to delay. What is the flip-flop delay or clock to delay? The time required to change the flip-flop output from clock edge occurrence is called flip-flop delay or clock to delay. What is setup time? The minimum time required inputs to be stable before occurrence of the clock edge is called setup time. What is hold time? The minimum time required inputs to be stable after clock edge occurrence is called hold time. Hold time. the time required to change flip-flop output from clock edge occurrence is called flip-flop delay or CK to clock to Q delay. Now, T setup or setup time, let me write it. Setup time. What is setup time? The minimum time required inputs to be stable before occurrence of clock edge is called setup time. Next, hold time. The minimum time required inputs to be stable after clock edge occurrence is called hold time. It's called hold time. This is what the definition we must know. There is a flip-flop properties or characteristics we need to understand. We need to understand the flip-flop properties. Circuit need not to be recognized. A flip-flop which we are constructing is responding to its input at respective edge only. Sai Kumar. So someone is not there who is observing again. Please understand. Its property is that. A flip-flop property is that. Right? What is it, Pawan Kumar? I did not understand. Yes, Pratik Pramod, I was doing the same. And yes, that's what I was doing. I have written Bharat Chandra. Please check it. So, how it recognizes means what is there to recognize? Its property, it behaves like that. Someone is not there who is observing whether it is responding to positive edge or negative edge. Like I'm monitoring you, whether you are following the class or not. No, someone is not there. So do you think that there is a circuit in that there is a flip-flop? Circuit is giving input at aspect. No, no. So we should make it work without fail. That is called static timing analysis. A big concept which you are going to study in your PG, or if you become an electronic engineer in digital domain, sure you must know all those. So when you are place and route your IC, right? Then after that, depending on wire delays and all, you need to make it by estimating propagation delays of each and every logic gate, each and every wire. You need to fix the problems without fail. It has to work. When it is propagating from one flip-flop to another flip-flop, then you need to make it work. So all this you will understand. Please hold on. So I'll try to give my best, which will help you in exams as well as any interviews also. If you are attending, it may be useful. So the information I'll give. Until that, please hold on. So finally, what we have understood, what is the level triggered latch, what is edge triggered flip flop, what is the properties of flip flops. So how to draw that positive edge triggered flip flop as well as negative edge triggered flip flop, and we know how to draw that latch output also. How to draw latch output also. I hope no one is having any doubts. Now, after understanding the basics of flip flops, we are ready to design counters. Which here counters. Counters, we have two types. One is a synchronous counters. Other one is a asynchronous counters. Am I right? Another name for asynchronous counters we have is a ripple counters. What is it here? Ripple counters. Ripple counters. Synchronous and asynchronous. Synchronous and asynchronous. So what is synchronous counter? If clock is common for all the flip-flops, then it is named as a synchronous counter. If clock is not common for all the flip-flops, that is called asynchronous. But why it is called ripple counter, we can understand later. At this moment, simply, if clock is common for all the flip-flops, then it is called synchronous. If clock is not common for all the flip-flops, asynchronous. If all the flip-flops are sensing to the inputs at common point of time, then it is called synchronized all the flip-flops. All the flip-flops are synchronized. That is called synchronized or synchronous. If it is not common for all the flip-flops, then all the flip-flops are not responding to inputs at common point of time. So it is called asynchronous. It is called asynchronous. Now let us start with the synchronous counter. Synchronous counter. Synchronous counters. It is synchronous counters. What is that synchronous counters? Let us see. What is it here? When clock is common for all the flip-flops, then we say it is synchronous counter. That means at every clock edge occurrence, all the flip-flops are sensing to its input. Then at every clock edge occurrence, if there is a change in flip-flop output, those changes will occur at respective edges. So now in the synchronous counters, let us start with the design. Simple thing. Design 2-bit binary up counter. Binary up counter using D flip-flops. Using D flip-flops. Design 2-bit binary up counter using delay D flip-flops. Then let us see how it can be done. So what is it here we are using is right? We have two columns. Before occurrence of the clock edge, if Q1, Q0 is 0, 0, after occurrence of the clock edge, we are expecting Q1, Q0 must become 0, 1, incrementing. Q1, Q0, if it is 0, 0 before occurrence of the clock edge, after occurrence of the clock edge, it becomes 0, 1, incrementing. Am I right? So once again, it can change where? Again at next clock edge occurrence. Again at next clock edge occurrence, Before occurrence of the clock edge it is 0, 1. After occurrence of the clock edge it is 1, 0. Writing the sequence. At next to next clock edge occurrence, what is that here? 1, 0 to 1, 1. At next clock edge occurrence again 1, 1 to 0, 0. This is the expected sequence. Expected sequence. Try to understand correctly. We are writing the two columns. One is before occurrence of the clock edge, other one is after clock edge occurrence. This is named as present state. This is named as a next state. Understand correctly. Each and every word is important. So this column, whatever we are writing is present state, which is before occurrence of the clock edge. And the next state we are writing is after occurrence of the clock edge. To get these changes, what is the flip-flop inputs? If I say D1, D0, if I say D1, D0, because we are using D flip-flops. So what should I write here is assuming respective flip-flop present state is Q of n, next state is Q of n plus 1. Present state is Q of n, next state is Q of n plus 1. What should we give inputs? That is called excitation table. With the help, sorry, with the help of excitation table, we are filling this D1, D0. We are filling this D1, D0. Once again, here what is happening here? Present state and next state. Present state is Q of n, next state is Q of n plus 1. Assuming this for the respective flip-flops, we need to write required flip-flop inputs, which is nothing but excitation of the flip-flops. Excitation of the flip-flops. So with the help of excitation table, yeah, Ravindra Swami, I will help you. Please hold on. Dinesh Sai, that will be discussed in the advanced concepts. Please hold on. Setup time equation and hold time equation. When we understand that, when we are understanding two flip-flops communication only, right? When two flip-flops are communicating, then we can understand. We are talking about only one flip-flop. Just we started designing bit counters. Then hold on. After understanding all these, I will give you whatever you are expecting. Right? Not assuming. So at every clock edge occurrence, whatever changes we are expecting, we are writing. Annapurni. So in the consecutive clock cycles, first clock edge 0, 0 to 0, 1, next clock edge 0, 1 to 1, 0, next clock edge 1, 0 to 1, 1, and next clock edge 1, 1 to 0, 0. Again repeating. That's what we are expecting, not assuming. So while analyzing, before occurrence of the clock edge will be obviously assuming ourselves at the clock edge occurrence. What is that here? You are at the clock edge occurrence. At that present moment, before occurrence of the clock edge available is what? Present state. I want to see next state. That is what we are going to see after clock edge occurrence. Assuming ourselves sitting at clock edge occurrence, looking at the counter. What is that here? Before occurrence of the clock edge, what we have is present state. After occurrence of the clock edge, what we have is next state. So we want to get next state. To get next state, I need to provide the inputs. If I provide expected input at this clock edge occurrence, then only it is possible to see next state which you are expecting. Am I right? Based on the present state, what is the inputs I can apply? That we say excitation, because we know what is available before occurrence of the clock edge. We know what we are expecting after clock edge occurrence. When we know that present and next, we know that Q of n and Q of n plus 1. I can say what should I apply at inputs to get changes we are expecting. So you are at the clock edge occurrence. At that point of time, you are observing. Before occurrence of the clock edge, what we have? Present state. After occurrence of the clock edge, what we have? Next state. To get this present to next transition, I need to provide the inputs. Then only it is possible to get changes we are expecting. For that, we say excitation or flip-flop inputs. Excitation or flip-flop inputs. Yes, wait, Anand, wait, Anand. Yes. As it is D flip-flops, advantage is, what is the excitation of the flip-flops? What is the D flip-flop excitation? 0 to 0, 0 to 1, 1 to 0, 1 to 1. What should we apply at inputs? right? Whatever you are expecting on Q of n plus 1. Whatever you are expecting on Q of n plus 1, right? So simply I can write next state as flip-flop input because these are D flip-flops, not for all, not for all. As it is D flip-flop, excitation is very simple. What is that? Whatever you are expecting on Q of n plus 1 must be given on D input, must be given on D input. So Q1 0 to 0, what must be here? 0. Q0 0 to 1, what must be here? 1. Q1 0 to 1, it is a 1. Q0 1 to 0, it is a 0. And Q1 1 to 1, it is a 1. Q0 0 to 1, it is a 1. Q1 1 to 0, it is a 0. Q0 1 to 0, it is 0. Simply, the next state is becoming flip-flop input because these are D flip-flops. Not for all the flip-flops, only for D flip-flops. Simple thing is next state can be copied as flip-flop input because Q of n plus 1, Q of n plus 1 is excitation of D flip-flops. I hope everyone is carrying those tables. Have you written all these tables in a page? Have you written all these tables in a page? Do you have these tables with you now? Yes. Okay, many are responding. It is a yes. Okay. 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 Thank you. Thank you. But utilize that suggestions correctly because instead of flipping pages or instead of searching for that slide and so, it is very difficult. There is a reason always I suggest carry the page with all these tables of flip-flop, characteristics, truth table, and excitation table. Carry this page till the completion of sequence of circuits. It must be with you side by right. Now, after writing excitation of the flip-flop inputs, now I need to write expression for D1, D0 in terms of Q1, Q0. I need to write expression for D1, D0 in terms of Q1, Q0. Which Q1, Q0 I need to use? Is it present state or next state? Once again, I need to find expression for D1, D0 in terms of Q1, Q0. The Q1, Q0, we have two columns. One is present state, one is next state. Which one should I use? Which one should I use? Present state or next state? Yes. Many have been saying that the present state, let me say the reason also. Reason also. Yes, it is present state is correct. The reason is the next state we are going to see after clock edge occurrence, right? The next state we are going to see after clock edge occurrence. But I need to provide inputs before occurrence of the clock edge itself. Try to observe, understand correctly. At the clock edge occurrence, next state we are going to see after clock edge occurrence. But I need to provide inputs before occurrence of the clock edge. Then what should I do? Based on the existing before occurrence of the clock edge, I need to provide the inputs. And after clock edge occurrence, we are going to see next state after responding to these inputs. After responding to these inputs, we are going to see next state. If I use next state to derive the inputs, again it becomes a non-causal system. With respect to signal terminology, we can say it is non-causal system. Future output cannot be used to derive the inputs presently. If you are designing such system, it cannot be realizable. That's what we say in signals and systems. So here once again what we say here, next state we are going to see after clock edge occurrence. Present state which is available before occurrence of the clock edge. So I need to provide inputs before occurrence of the clock edge itself. For that I can use the state which is available before occurrence of the clock edge. Before occurrence of the clock edge, the state available is what? Present state. Using Q1, Q0 column, present state column, let us find expression for D1, D0. What is D1 now? These two are 1. Which are those? Q1, Q0, 0, 1 and 1, 0. Q1 bar, Q0 plus Q1, Q0 bar, which is Q1 XOR Q0. Q1 XOR Q0. What about D0? These two are 1. Right? So what is it here? 0, 0 and 1, 0. Understand correctly? So we are using present state column of Q1, Q0 to find expression for D1, D0. What about D0? Q1, Q0, 0, 0. Q1, Q0, 1, 0. That means Q1 bar, Q0 bar plus Q1 Q naught bar, which is a Q naught bar, which is Q naught bar. Simply writing expressions on Q1 Q naught using present state column, Then let us write a counter circuit. Let us write a counter circuit. Let us write a counter circuit for this binary up counter. 2-bit binary up counter using delay flip flops. Using delay flip flops. Then what can we write here? The counter is D naught, Q naught, Q naught bar. So D naught is connected to Q naught bar. D1 is connected to Q1 XOR. This is XOR gate. This is XOR gate. Q1 XOR Q naught. And synchronously clock. The synchronous counter, synchronously clock. What is it here? D naught is Q naught bar. D1 equals to Q1 XOR Q naught. Q1 XOR Q naught. D naught is Q naught bar. D1 is equals to Q1 XOR Q naught. This is a 2-bit binary up counter, which is counting from 0, 0, 0, 1, 1, 0, 1, 1, again back to 0, 0, again back to 0, 0. Shivalila, you are at next level. That we do analysis in FSM by observing number of states, how many minimum number of flip-flops required, that we are going to do later. Depending on number of states, we can say number of flip-flops. If n is number of states, that n must be less than or equals to power n. The small n value is giving minimum number of flip-flops. So the minimum n value which is satisfying this equation is a minimum number of flip-flop. What is small n? Number of flip-flop. What is capital N? Number of states. Please, whatever the doubts you have with respect to your earlier knowledge, so that doubts you can ask either in WhatsApp or in the question hour while discussing. If you have any doubts in this, please answer or ask questions based on these. So you may be getting a doubt with respect to your previous coaching or with your previous discussions. You may be getting doubt. I was getting a doubt about the minimum number of flip-flops and all. So that will be understood later. Hold on. So yes, whenever it is required to design a counter which is going through a specific sequence, depending on that, I'm going to decide number of flip-flops also. Sometimes there may be repeated states also, like which are given in a CSC paper 0, 0, 1, 1, 2, 2, 3, 3 back to 0. How many flip-flops? Or 0, 1, 0, 2, 0, 3 back to 0. How many flip-flops? These type of questions I will answer. Please understand the discussions which I am doing. So with respect to your questions, I will answer. So let me follow my sequence. When I have been conveying the concepts slowly, so you are trying to understand, I hope. I hope you are understanding concepts in a right way, because I have been said, have said this in a correct sequence. So let me follow that sequence. So with respect to your questions, I will answer later. Please understand. Are you understanding what I've been discussing? Concepts. If you are understanding concepts correctly, you should get a addiction of digital circuits. As I mentioned already, you should feel that when you find a question, let me solve, that confidence must be there. If you are observing yourself that you are done with 10 marks in GATE exam and around 20 to 30 marks in ESC. So that confidence you need to get after this. Every point, every concept is very important to score this 100%. easy subject, but there is a possibility for doing mistakes with assumptions. As we have some assumptions in this, instead of understanding each and every point correctly, we are assuming ourselves something. So that is the reason I have been giving that each and every point clearly. So I did not say that this is like this. No, no. Let us understand why it is like that. Why we are getting setup time, why we are getting hold time. So that's what we are understanding. That is required for our competitive exams. That is the reason I'm trying to build the basics correctly. Then you can play with the subject. That's what I feel. So anyone has any questions in this designing 2-bit binary up counter? Next. Question is again design 2-bit binary down counter using D flip-flops. Now it is down counter. What is down counter? Decrementing the sequence. Shubham Kumar, we are deriving inputs based on present state. Present state is not input. So while deriving inputs, the combinations we are considering is present states. So input combinations we are considering, correct, but it is not inputs, it is a state. Based on the state, we are deriving expected inputs. The inputs are ready, then flip-flops are responding to inputs. We are going to see expected next state. That's what we need to understand. So present state we are considering as the inputs to derive flip-flop input expression. But that is not input actually. It is a state itself. Based on the state, we are deriving the inputs. Inputs are ready, flip-flops are responding to inputs. We are going to see next state we are expecting. That's what we need to understand. Yes, design 2-bit binary down counter using delay D flip-flops. Delay D flip-flops. Let us see what is it here. Q1, Q0, Q1, Q0. What is it here? 0, 0, sorry. Down counter. Let me go with the down counter. 1, 1 to 1, 0, 1, 0 to 0, 1, 0, 1 to 0, 0. From 0, 0 to again 1, 1. Again 1, 1. What is this here again? Present state, next state. What we are observing here? 3 to 2, 2 to 1, 1 to 0, again back to 3. Then flip-flop inputs. What is it here? D flip-flops. Very simple. What is it here? Same. We can copy next state as a flip-flop input for only D flip-flops. Be clear about that. So 1 to 1 it is 1, 1 to 0 it is 0. Again 0, 1 and 0, 0. It is a 1, 1. It is 1, 1. Then find expression for D1, D0 in terms of Q1, Q0. D1, D0 in terms of Q1, Q0. Present state. So D1 is what? These two are 1. Which are those? 1, 1 and 0, 0. Q1, Q0 plus Q1 bar, Q0 bar. Which is a Q1 XNOR Q0. What about D0? These two are 1. Which are those? 1, 0, 0, 0. Q1, Q0 bar plus Q1 bar, Q0 bar. Again it is Q0 bar only. Then what we can do here? Again, drawing counter circuit. This is a counter circuit using delay flip-flop, which is counting down. Which is counting down. Which is counting down. I hope everything is clear till now. design 2-bit binary up and down counter, up and down counter using D flip-flops with a control signal x equal to 0, then up counter, x equals to 1, then it must be a down counter. X equal to 0, then up counter, x equals to 1, it is a down counter. X equal to 0, then it is up counter, x equals to 1, it is a down counter. So it must be working as up counter as well as down counter. If you are clearly observing, this is up counter, this is down counter. Then what is the difference between these two? Here D naught is Q naught bar, here D naught is Q naught bar. In this it is XNOR, in this it is XOR. The difference is D1 only. For up counter and down counter, the major difference is what? Only D1 expression. D1 is XOR up counter, D1 is XNOR down counter, XNOR down counter. So I designed this in a simple way like this. D1, Q1, Q1 bar, D naught, Q naught, Q naught bar. D naught is fixed, but D1 is controlled. D1 is controlled. Depending on counter we are expecting. Depending on counter we are expecting. What is it here? Let me use here XOR. If you are applying XOR, it becomes up counter. If you are applying XNOR, it becomes a down counter. For this reason, let me use here the multiplexer control signal. Select line is connected to X, and here X equal to 0 up counter, X equals to 1 down counter. Simple way. That is simple way. I hope you are understanding correctly. So only difference is X equal to 0, X equal to 0, multiplexer output is what? XOR. If it is XOR, up counter. If X equals to 1, what we get here? One line. So what we are getting on this XOR followed by NOT gate, it is XNOR. So when D1 is XNOR, it works as a down counter. Simple. It is very simple. It works as a up counter as well as down counter. X is a control signal which is controlling whether it works as up counter or down counter. Up counter or down counter. I hope you are following. Simple counter. 2-bit binary up and as well as down counter. Up as well as down counter. Moving to next slide. Or you can modify this. Again, this becomes XOR only. Because X bar Y. If I say it is Y and X Y bar. The functionality of this is what? X bar, if I say it is Y, X bar Y plus X Y bar. S bar I naught plus S into I1. In place of S, what we have here? X. X bar Y plus X Y bar is nothing but X XOR Y. Again, this can be 2-input XOR only. 2-input XOR only. What I can do here? This can be replaced with the 2-input XOR. 2-input XOR. One is X. Here we have XOR gate output. Right. Again, XOR followed by XOR. This entire is equals to again what? 3-input XOR. 3-input XOR. Your wish. If you keep on extending, analyzing, you'll be getting some more ideas. So I'm simply analyzing what is it here. It is multiplexer is sufficient because I have in a mind what is that here? X equal to 0 up counter, X equals to 1 down counter. Difference is what? X equal to 0, D1 must be getting XOR, X equals to 1, D1 must be getting XNOR. That's what we are writing here in this using multiplexer. After that, what we are observing? This is also it is XOR function only because X bar Y plus XY bar. So I'm replacing with XOR. So XOR followed by XOR is becoming again 3 input XOR. Simple. So what is inputs here? X, Q1, Q0. 3 input XOR. One is X, other one is Q1 and also Q0. Here it is what? Q1, Q0. Here it is X. That's it. Step by step, we can simplify the circuit if you are logically analyzing. Moving to next slide. Binary up counter using T flip-flops, using toggle flip-flops. What I should know, I should have to do now, designing 2-bit binary up counter using toggle flip-flops. First, let me write what is the sequence we want to design. Q1, Q0 present state, Q1, Q0 next state. 0, 0 to 0, 1, 0, 1 to 1, 0, 1, 0 to 1, 1, 1, 1 to 0, 0. What is this here? Up counter. What is here? Up counter. Because 0 to 1, 1 to 2, 2 to 3, 3 to 0 again. Then I need to get a flip-flop inputs. Here you need to focus. What is the flip-flop, sir? T1, T0, T flip-flops. I know what is the excitation. Simple thing. What is it here? Q of n plus 1, then toggle flip-flop T input. 0 to 0, T is 0. 0 to 1, 1, 1 to 0, 1, 1 to 1, 0. Already I discussed this, sir. Follow this once again. State is same 0, state is complementing 1, state is complementing 1, state is not changing, it is 0. Same 0, complementing 1. Toggling 1, if it is not required to toggle, it is 0. So what we say here, Q1, 0 to 0, same 0. Q0, 0 to 1, complementing, T is 1. 0 to 1, Q1, 0 to 1, it is a 1. 1 to 0, it is 1. 1 to 1, it is 0. 0 to 1, it is 1. 1 to 0, it is 1. 1 to 0, it is 1. I hope you are clear with the excitation tables. Then what we get expression here, T1 is equals, these two are 1. Which are those? 0, 1 and 1, 1. Present state we are observing. Already we discussed reason for using present state. T1 is 1 for these two. Which are those present states of Q1, Q0? 0, 1 and 1, 1. So Q1 bar Q0 plus Q1, Q0, which is Q0. Minimize it. What about T0? For all the combinations, it is 1. It is 1 only. It is 1 only. Right. Let me write expressions already written. Then write the circuit using toggle flip-flops. Using toggle flip-flops. T1, Q1, Q1 bar. Then here it is T0, Q0, Q0 bar. T0 is 1. T1 is connected to Q0. Then synchronously clock. Synchronously clock. This is a 2-bit binary up counter using toggle flip-flops. Shweta Sharma, what happened? XNR Q naught bar. What is there to understand in this? Down counter Q1 XNR Q naught. Reason is these two are one. What are these? Q1 Q naught 1 1, Q1 Q naught 0 0. That is the reason Q1 Q naught plus Q1 bar Q naught bar. What it becomes? Q1 XNR Q naught. What about D naught? These two are 1 1 0 and 0 0. That means Q1 Q naught bar plus Q1 bar Q naught bar. What is this here? Q naught bar. Q naught bar. Shweta. Yes, we are making it to work. Sajjan Singh, we are making it to work. So it is state is generated, then again it must be ready with the inputs required for next state. So it is made to work as expected. Right? We are not giving inputs. We are designing a counter on its own. It is able to generate the expected inputs to change the next state. Automatically, it is doing on its own. Further, we are designing. So it cannot has its own knowledge to get expected inputs. So we are making it to work as expected. Sajjan Singh, understood correctly? Right now, okay. After this, design 2-bit binary up counter using JK flip-flops. JK flip-flops. So what should I do now? Again, designing 2-bit binary up counter using JK flip-flops. 0 0 to 0 1, 0 1 to 1 0, 1 0 to 1 1, 1 1 to 0 0. Then present state, next state, flip-flop inputs. What is it here? J1 K1, J0 K0. And now I know excitation table of JK. Q of n plus 1 and JK. 0 to 0 it is 0 don't care. 0 to 1 it is a 1 don't care. 1 to 0 which is don't care 1. 1 to 1 it is don't care 0. I hope you might be having all these tables. Just I am giving for a reference. So let me do that. Now Q1 I am observing 0 to 0 it is a 0 don't care. Q0 0 to 1 it is a 1 don't care. Am I right? Respectively flip Q1 0 to 0 0 don't care. Q0 0 to 1 1 don't care. Now Q1 0 to 1 it is a 1 don't care. And Q0 1 to 0 which is a don't care 1. And again now 1 to 1 don't care 0. And 0 to 1 it is a 1 don't care. And 1 to 0 which is a don't care 1. 1 to 0 again don't care 1. Don't care 1. Now let us find Boolean expressions of J1, K1, J0, K0 in terms of Q1, Q0. Simple thing is, let me write two variable K map because we have don't care, sir. Don't get confused. So write K map and get the expression. J1 I am writing. J1 in 0, 1 it is 1. 1, 0 it is don't care. 1, 1 it is don't care. Then What is here? J1 is equals to Q naught. Here it is a Q1 Q naught 0 1 0 1. What is here? K1 0 0 is don't care, 0 1 is don't care, and 1 1 is 1. Again K1 is also Q naught. For J naught, what is it here? 1 don't care, 1 don't care. Then it is a 1. J naught is 1. Either min terms or don't cares only. Then again here it is a Q1 Q naught 0 1 0 1. Again what is it here? Don't care 1, don't care 1. Again K naught is also 1. K naught is also 1. Then draw the counter circuit. J naught K naught connected to 1. J1 K1 connected to Q naught. Simple thing. Next, moving to next slide. Design 2-bit gray counter using JK flip-flops. Please complete on your own. Take 2 minutes. So please complete, everyone. Please try. So, gray counter, the sequence we know. Let me write the sequence first. Q1, Q naught, present state Q1, Q naught, next state. What is it here? 0, 0 to 0, 1, 0, 1 to now 1, 1, 1, 1 to 1, 0, 1, 0 to 0, 0. Present state and next state. Which flip flops, sir? JK flip flop. Flip flop inputs. J1 K1 J0 K0 JK flip flops. J1 K1 J0 K0. Then what we have here? Q1 0 to 0. 0 don't care. Right? Q0 0 to 1. It is a 1 don't care. 0 to 1, 1 don't care. 1 to 1, don't care 0. 1 to 1, don't care 0. 1 to 0, don't care 1. 1 to 0, don't care 1. 0 to 0, 0 don't care. 0 don't care. Then find expression for J1, K1, J0, K0 in terms of Q1, Q0. Then finding expression for J1, K1, J0, K0 in terms of Q1, Q0. So using two variable K map, because we have don't take a chance. Write the K map and find the expression 0, 1, 0, 1. What about J1? 0, 1 is 1. 1, 1 and 1, 0 are don't cares. Then this is the grouping. Then J1 is equals to Q0. Here again, what is that here? Q1, Q0, 0, 1, 0, 1. What we have in K1? 0, 0 is don't care. 0, 1 is don't care. And where it is 1? Check it correctly. It is not here. It is 1, 0 is 1 means I need to write 1 here. Be clear about that. Last one is 1, but last one is not 1, 1. Last one is 1, 0 with respect to Q1, Q0. So I need to write 1 here. So this is the grouping we get. K1 is equals to Q0 bar. Check it correctly. There is a possibility for doing mistake. Last one is 1. Last one means you may be writing 1 here. Then again it is resulting Q0 will be wrong. So here it is 1, but Q1, Q0 present state combination is 1, 0. It is 1 means I need to write 1 here. And again, J0 and K0. What is it here? J0. 0, 0 is 1. 0, 1 is don't care. 1, 1 is don't care. Then J0 is equals to Q1. What about K0? 0, 0 is don't care. 1, 1 is 1. 1, 0 is don't care. Then K0 is equals to somewhere in, yes, Q1 bar. It is a Q1. It is Q1. Yes, correct. Here, if I write a counter circuit J1, K1, Q1, Q1 bar. And again, J0, K0, Q0, Q0 bar. J0 connected to Q1 bar, K0 connected to Q1, and J1 connected to Q0, K1 connected to Q0 bar. Then synchronously clocked. Synchronously clocked. Clock must be called. Correct. This is a gray counter using JK flip flops. Moving to next slide. Using zero, 2, 3, 1, back to 0. Shilpa. What is there in that? Gray count, 2-bit gray counter. Gray sequence 0, 0, 0, 1, 1, 1, 1, 0. Again back to 0, 0. How to write gray codes I mentioned. How to get gray codes also I discussed. Shilpa. Shilpa Balbin Kumbar. Still you have any doubt, I'll help you. Don't accept as I mentioned your name. So 2-bit gray code already we discussed 0, 0, 0, 1, 1, 1, 1, 0. That's what I've used here also. 0, 0, 0, 1, 1, 1, 1, 0. Again back to 0, 0. 0, 0, 0, 1, 1, 1, 1, 0. Again back to 0, 0. The sequence we have used 0, 0 to 0, 1. 0, 1 to next 1, 1. 1, 1 to 1, 0. 1, 0 to 0, 0. From 0, 0 again 0, 1. Right? Going through. And how to get gray codes also I mentioned. If you are not remembering, use a K-map. For 2-bit gray codes, 2-variable K-map. A, B, 0, 1, 0, 1, 0, 1, 2, 3. What is 3 order? 0, 1, 3, 2. Shilpa. Thank you. So now I need to design this counter. What is it here? Q1, Q0, present state Q1, Q0, next state. 0, 0 to 1, 0, 1, 0 to 1, 1, 1, 1 to 0, 1, 0, 1 to 0, 0. Correct? It is mentioned 0 to 2, 0, 0 to 1, 0, 2 to 3. So 1, 0 to 1, 1, 3 to 1, 1, 1 to 0, 1. So 1 to 0, 0, 1 to 0, 0. Then flip-flop inputs T1, T0. Then 0 to 1, it is 1, 0 to 0, it is 0. Excitation, toggle flip-flop. Complementing 1, same, 0 to 0 means same 0, 1 to 1 same 0, 0 to 1 it is complementing 1. Next again, 1 to 0 complementing it is 1, 1 to 1 it is same 0, 0 to 0 it is 0, 1 to 0 it is 1. I hope you are able to write excitation easily. State is changing, T is 1. State is not changing same, then it is 0. Then we need to find expression for T1 and T0. T1 is 1 for these two. Which combinations of present 0, 0 and 1, 1? Check it correctly. These two are ones. 0, 0 combination, 1, 1 combination. Q1 bar, Q0 bar plus Q1, Q0, which is a Q1 XNOR Q0. What about T0? These two are 1, right? 1, 0 and 0, 1. Q1, Q0 bar plus Q1 bar and Q0, which is a Q1 XOR Q0. Yovish, how you are going to use this logic circuitry? So it is a XNOR and here it is XOR. Yes, Anand. So by this time, you may be getting it out. How do we get questions in objective exams on counter design? Right? So how do we get questions in objective exams based on this counter design? If you are having such doubts, let me give you clarity. Question is this. What is the question is, if the following counter is going through 0, 2, 3, 1 back to 0, then what is that X? Question is given. 4 options are given. Question is, if the following counter is going through 0, 2, 3, 1 back to 0, then X is equals to. 4 options are given. This we can do with counter design. With the counter design. We know what is the X, right? What is the X? Q1 XOR Q0. This was the question given in previous GATE exam. Using toggle flip-flops. Design 3-bit binary up counter using toggle T flip-flops. Simple thing. You'll see that 3-bit binary up counter. Q2, Q1, Q0 present state. Q2, Q1, Q0 next state. 0, 0, 0 to 0, 0, 1 binary up counter. 0, 0, 1 to 0, 1, 0 incrementing. 0, 1, 0 to 0, 1, 1. 0, 1, 1 to 1, 0, 0. 1, 0, 0 to 1, 0, 1. 1, 0, 1 to 1, 1, 0. 1, 1, 0 to 1, 1, 1. 1, 1, 1 to 0, 0. This is what we have. State changes in 3-bit binary up counter. If it is flip-flop input, which flip-flops are used? Toggle flip-flop. So T2, T1, T0. Then I can write excitation also easily. What is that? If state is changing, T equals to 1. If state is not changing, T equal to 0. 0 to 0, it is 0. 0 to 0, Q1, 0 to 0, it is 0. Q0, 0 to 1, it is 1. Again, 0 to 0, it is 0. 0 to 1, it is 1. And 1 to 0, it is 1. And 0 to 0, it is 0. 1 to 1, it is 0. 0 to 1 is 1. And 0 to 1 is 1. And 1 to 0, it is 1. 1 to 0 is 1. And 1 to 1 it is 0, and 0 to 0 it is 0, 0 to 1 is 1, and 1 to 1 is 0, 0 to 1 is 1, 1 to 0 is 1. Then again 1 to 1 it is 0, 1 to 1 it is 0, 0 to 1 is 1. Then again 1 to 0 is 1, 1 to 0 is 1, 1 to 0 is 1. Then finding expression for T2, T1, T0 in terms of Q2, Q1, Q0 present states. Let me give input combination numbers. 0, 1, 2, 3, 4, 5, 6, 7. Then T2 is equals to sigma m of 3 and 7. Check it correctly. Sigma m of 3 and 7. T2 is 1 for these two. Which combination of Q2, Q1, Q0? 3 and 7. T1 is equals to sigma m of what we have here? 1, 3, 5, 7. 1, 3, 5, 7. What about T0? Sigma m of 0 to 7. 0 to 7. Now, let me use K-maps to find expressions with Q2, Q1, Q0. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. What is that here? 3 and 7. So, T2 is equals to Q1, Q0. Similarly, Q2, Q1, Q0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. And what is it here? 1, 3, 5, 7. T1 is equals to Q naught. What about T naught is equals to 1? Then we can write a counter circuit. 2-bit binary up counter. T naught, Q naught, Q naught bar, T naught connected to 1. And again here, what do we have here? T1, Q1, Q1 bar, T1 connected to Q naught. Once again, what we have here? One more flip-flop with T2, Q2, Q2 bar, T2 connected to Q1 and Q naught. There is a synchronous drop. Why I have used in this order also we can understand, because you might have doubted, right? First must be T2, next T1, T naught. So whatever the order you are designing for display, we can go with the order expected. We can go with the order expected. That's what Arpit Ananda. That's what I've been saying. Don't think that the left must be MSB, right must be LSB. You always, while designing for your convenience, you may change your order. But for display, after designing counter where we are going to display, right? By using LEDs, we can display that. What is it here? Q2, X1, Q0. That I can take order. Not a problem, I'm saying. If you want to design in leftmost is MSB, rightmost is LSB, if we are using that convenience only, then follow that. Not a problem. But what is the use of this order is, if I want to design 4-bit binary up counter, simple thing is T3 will be Q2, Q1, Q0. Check it correctly. T3 will be Q2, Q1, Q0. Check it correctly once again. So we have one more flip-flop. There will be having that Q2, Q1, Q0. T3 is equals to Q3, Q2, Q1, Q0. So you can design that 4-bit also later, not now. Here if I say T3, Q3, Q3 bar, T3 connected to what is it here? Q2, Q1, Q0. Correct. T3 is connected to Q2, Q1, Q0. If I would like to design one more counter or one more bit counter, which is 5-bit counter, then what can be that? Let us see. Here it is T4, Q4, Q4 bar. Then T4 is connected to Q3, Q2, Q1, Q0. So Q3 is ANDed with Q2, Q1, Q0 we have in this. Let me use. You can extend one more bit counter. So one more flip flop, one more AND gate, one more flip flop, one more AND gate. Extending number of bits. Extending number of bits. There is advantage of using this order. That is advantage of using this order. Right? using toggle flip-flops. Now what is it here? Mod 6 synchronous up counter using toggle flip-flops. For more number of flip-flops, use lab for first flip-flop. I did not understand, Anand. Whenever it is required to display in the order we are expecting, we can go with the order. Bhaskar, if you want to display Q2, Q1, Q0, for display we can pull with wires. We can get connections in the order. Right. Right. That's what I'm going to talk. Mod 6. Sajjan Singh. What is it? Mod 6. What is the modulus of counter? What is modulus of counter? Modulus of counter. The number of distinct states. Distinct states. Counter is repeating. Number of distinct states counter is repeating is called modulus of counter. Whenever it is a modulus is asked, how many states a counter is repeating? That is called a modulus of counter. That is called modulus of counter. The number of different states counter is repeating is called a modulus of counter. It's not maximum possible states. Toy. Please understand this correctly. Maximum possible states. If I use n flip-flops, I get to power n state. That is called maximum possible states. No. What is the modulus of counter? A counter which is getting repeated. What is the sequence it is going through? In that, how many states are different states it is repeating is called modulus of counter. The number of distinct states counter is repeating is called modulus of counter. So every cycle, in a cycle, it is repeating, right? So which states it is repeating? How many different states it is repeating? That number of states repeating is called modulus of counter. Now complete this mod counter. Designing mod 6 synchronous up counter using toggle flip-flop. Then what we can write as it is up counter, assume that it is starting with 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, so 0, 0, 0 to 0, 0, 1, 0, 0, 1 to 0, 1, 0, 0, 1, 0 to 0, 1, 1, 0, 1, 1 to 1, 0, 0, 1, 0, 0 to 1, 0, 1, 1, 0, 1 to 0, 0. Present state, next state. Present state, next state. Then what should I do? Flip-flop inputs. Flip-flop inputs. Which flip-flops? T2, T1, T0. Why it is from 101 to 000? It is already counted 0, 1, 2, 3, 4, 5. That means the number of counts is 1, 2, 3, 4, 5, 6. So number of states is already 6. After 101, again back to 000. So number of states must be 6 only. So it is 0 to 5 is 6 states. It is counting 0 to 5. It is 6 states. So now excitation. 0 to 0, it is 0. 0 to 0, it is 0. 0 to 1, it is 1. And 0 to 0, it is 0. And 0 to 1, it is 1. And 1 to 0, it is 1. And 0 to 0, it is 0. And 1 to 1, it is 0. And 0 to 1, it is 1. Then again, 0 to 1, it is 1. And 1 to 0, it is 1. 1 to 0, it is 1. Then again, 1 to 1, it is 0. 0 to 0, it is 0. 0 to 1 is 1. And again, 1 to 0 is 1. 0 to 0 is 0. 1 to 0 is 1. Find expressions for T2, T1, T0 in terms of Q2, Q1, Q0. In terms of Q2, Q1, Q0. Then what I can do here is, let me give input combination numbers Q2, Q1, Q0. 0, 1, 2, 3, 4, 5. Then T2 is equals to sigma m of what we have here 3 and 5. But what about 6 and 7? Unused states. Assuming that they never occur, those can be considered as a don't cares. Assuming 110, 111 never occurs, we are considering those are don't cares. Assuming 110, 111 never occurs in this counter, those can be considered as a don't care. So T1 is equal to sigma m of what we have here 1 and 3. 1 and 3 plus don't cares of 6 and 7. T naught is equal to sigma m of 0, 1, 2, 3, 4, 5 plus don't cares of 6 and 7. Don't cares of 6 and 7. And use 3 variable key maps to find expressions for T2, T1, T0. Complete that. Q2, Q1, Q0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. 3 and 5, 6 and 7 are don't cares. Then this is one grouping, this second grouping. Then what we get here? T2 is equals to Q2 Q0 plus Q1 Q0, which is nothing but Q2 plus Q1 and with Q0. What about T1? Let us see T1 expression. Q2, Q1, Q0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So 1 and 3, 6 and 7 are don't care. Then this is one grouping is sufficient. T1 is equals to Q2 bar Q0. No doubt T0 will be 1. Either minterms or don't cares. All our minterms are don't cares. That you can draw the counter circuit also. That you can draw counter circuit also. Complete it. Counter circuit also. T0, Q0, Q0 bar. T0 is connected to 1 and T1 is equals to Q2 bar Q0. Then what we have here is not required to write the circuit, but I'm completing this also. This is a counter design. This is a counter design. Now, second possible way we have been getting questions is a counter analysis. What is it here? When sequence is given, we have designed the counter. Now, counter will be given, we need to find the sequence. Point should be understood correctly. So, till now what we have done, sequence is specified, up counter, down counter, specific sequence, mod counter and so and so. When sequence is specified and flip-flops are specified, we have designed the counters. Now onwards, what the next phase is, when counter circuit is given, we need to find the sequence it is going. What is that? Let us see. Question is, in the following counter, assuming initially Q1, Q0 is 0, 0, the sequence of Q1, Q0 counter is going through. counter going through is a dash. So counter circuit will be given like this. D1, Q1, Q1 bar. Example I'm giving. And also here it is a D0, Q0, Q0 bar. Counter circuit will be given like this. Now I need to find what can be the sequence it is going through. What is the sequence it is going through? Then what should I do? Simple way. When sequence is given, we know present state and next state. When sequence is not given, what should we do? Start with present state. Based on the present state, what we do? We are deriving input, because when we have present state, I can say what is the inputs I'm applying. When I know present state and present input, I can estimate next state using characteristics of the flip-flops. While designing counter, we have used excitation table. While estimating next state, when we know present state, the next immediate step is what? Based on the present state, what is the inputs we are getting? Once we are knowing that present state and present inputs, we can estimate next state using characteristics of the flip-flop. Again, next state will be considered as present state and proceeding until sequence is repeating. Until sequence is repeating. What is that? Let us see here. So present state Q1, Q0. Based on the present state, what is the present inputs? D1, D0. Based on the present state and present input, estimating next state. What is D1 connected to? Q1 bar in this. What is D0 connected to? Q1 XNOR Q0. Remember once again, based on the present state only, we are deriving present inputs. Once we are getting present inputs and present state, I can say what is the next state using characteristics of the flip-flop. So initially what is mentioned? 0, 0. Based on the present state. Now let me derive the inputs. Follow correctly. Based on the present state, we are deriving present inputs. Based on the present state and present input, estimating next state using characteristics of the flip-flops. When Q1, Q0 is 0, 0, what we get? D1 and D0. D1 is Q1 bar means 0 bar is 1. D0 is Q1 XNOR Q0 means 0 XNOR 0 is 1. What is it here? 1. So based on the present state 0, 0, we are getting present inputs is 1, 1. What will be the next state? 1, 1. Because characteristics of D flip-flops is whatever we are giving on D input will be the next state. Q of n plus 1 is nothing but what we are giving on D. D characteristics is what? D is 0, Q of n plus 1 is 0. D is 1, Q of n plus 1 is 1. What is Q of n plus 1 here? Next state. So if D is 0, Q of n plus 1 is 0. D is 1, Q of n plus 1 is 0. Based on the present state, if I am getting present inputs D1, D0, I can say next state is whatever we are getting on D inputs, because these are D flip-flops. Characteristics of D flip-flops is whatever we are getting on D inputs will be the next state. Now, in the next clock cycle, what we do? Next state is copied as a present state. Next state is copied as a present state. Now, Q1 bar, 1 bar is 0. Q1 XNOR Q0. Help me that. 1 XNOR 1 is what? 1. What is the next state? 0, 1. Then 0, 1 becomes the present state now. So Q1 bar, 0 bar is 1. Q1 XNOR Q0. 0 XNOR 1 is 0. Next state is what? 1, 0. From 1, 0 again. What is it here? Q1 bar, 1 bar is 0. Q1 XNOR Q0, 0. Next state is what? 0, 0. Then repeating. So sequence 4 options will be given. We have to choose correct answer. 0, 0 to 1, 1, 1, 1 to 0, 1, 0, 1 to 1, 0. Again back to 0. Or in the decimal equivalent, we can say 0 to 3, 3 to 1, 1 to 2. Again back to 0. 0, 0 to 1, 1, 1, 1 to 0, 1, 0, 1 to 0, 0. Again back to 0, 0. Right? From 1, 0 again back to 0, 0. Simple way is based on the present state, from the counter circuit, we can write flip-flop input expressions. Check it correctly. From the counter circuit given, we can write flip-flop input expressions. Based on the present state, we are deriving present inputs. Based on the present state and present input, estimating next state using characteristics of the flip-flops. So as these are D flip-flops, characteristics of D flip-flops is nothing but present inputs will be the next state. Yes, that's what we are getting here. Sequence is what? 0, 3, 1, 2, back to 0. That is a 2-bit binary. Sorry, the sequence it is going through from the given counter. So simple thing is when we know present state and next state, we were estimating what is the inputs required. But we know the present state, then based on the present state, we are deriving inputs. Based on the present state and present input, we can estimate what can be the next state. Now, you may understand more with the next example. Hold on, Venkana, I will take with all. Don't need to worry. Not only one, not only with D flip-flops. Hold on. It may be difficult to you, right? I will help you. In first example itself, you are asking to go with JK, right? Let me go with that. Why do you want to saturate everyone? Let me feed step by step. In the following counter, initially Q1, Q0 is 0, 0. Then the sequence of Q1, Q0 is dash. I will take all the flip-flop, don't need to worry. Just wait. One by one, we are studying. T1, Q1, Q1 bar. Next, T0, Q0, Q0 bar. T0 is connected to 1, T1 is connected to Q0 bar and synchronously clocked. This is counter given. Yeah, will be uploaded, Lal Krishna. Yeah, Shubham Kumar, we are getting that sequence. We haven't taken. When 0, 0 is there, next state is 1, 1. From 0, 0, next we are getting 1, 1. From 1, 1, next we are getting 0, 1. From 1, 1, next we are getting 0, 1. From 0, 1, next we are getting 1, 0. From 1, 0, again back to 0, 0. It is not taken, it is what we are getting. Shubham. Abhijit, very simple. It is given counter circuit and it is mentioned what is initial, then present state. And what is the flip-flop inputs from the counter circuit? What is connected to D1? Q1 bar. What is D0 connected to? Q1 XNOR Q0. That's what I have written here, D1, D0 expressions. So based on the present state, we are deriving present inputs. Based on the present state and present input, estimating next state using characteristics. What is characteristics of D flip-flops? Whatever we are getting on inputs will be the next state. That's what I'm writing. As we are getting 1, 1 here, we are getting next state is 1, 1. So 1, 1 is considered as present state. Then again, we are getting 0, 1 as inputs based on these expressions. So next state will be 0, 1 because D flip-flops, whatever we are getting on D inputs will be the next state. 0, 1 is becoming present state. Then next state will be 1, 0. 1, 0 is present state and next state is 0, 0. So that's what we are getting here, sequence. Coming to this present state Q1, Q0. Present inputs T1, T0. Next state Q1, Q0. Observe correctly. What is T1 connected to? Q0 bar. T0 connected to 1. What is characteristics of toggle flip-flops? I'm writing characteristics also if you are having it out. 0 q of n, 1 q of n bar. 0 q of n, 1 q of n bar. Right? So what is initially 0, 0? Based on the 0, 0, let me derive inputs. What is input expressions? Already we have written here. So from the counter circuit, what we are getting? Flip-flop input expressions. Based on the present state, deriving present inputs. Q naught bar means 0 bar is 1. T naught is permanently connected to 1. Listen carefully. Listen carefully. T1 is 1. If T is 1, what we are expecting next state is complement of present. T1 is 1. Listen carefully, everyone. T1 is 1, then what you are expecting? Complementing the state. Which one? Q1 has to complement. As T1 is 1, Q1 has to complement. What is presently 0? What is the next complement of that? Means it is 1. So characteristics are giving what is the next state. As T is 1, next state is complement of present. As T1 is 1, next state of Q1 is complement of present, 0 complement is 1. As T0 is also 1, what we are expecting? Q0 has to complement. T0 is 1, Q0 is 0, complementing 0 complement is 1. I hope you are understanding how we are getting 1, 1. How we are getting 1, 1? It is not because of T1, T0 is 1, 1. Observe correctly. T1 is 1, complementing Q1, 0 complement is 1. T0 is 1, Q0 is complementing, 0 complement is 1. Yes, it is 1, 1. The 1, 1 is becoming again present state. Based on this present state, let me derive a present inputs. What is it here? Q0 bar. 1 bar is 0. Q0 bar means 1 bar is 0. T0 is connected to 1. T0 is connected to 1. T1 is 0. T1 is 0 means Q1 must remain in the same. Next is present only when T equal to 0. Yes, T1 is 0 means Q1 is same as present. Observe correctly. T1 is 0 means Q1 same as present. What is T0? 1. T0 is 1 means Q0 is complementing. 1 complement is 0. Check it correctly. T equal to 0, same as present. T equals to 1, next is complement of present. Yes. So when T1 is 0, Q1 is remaining same. T0 is 1, Q0 is complementing. Yes. 1, 0 is becoming present state. Now again, based on this 1, 0, present inputs. Q0 bar. 0 bar is 1. T0 is also 1. So T1 is 1. Q1 is complementing. T1 is 1. Q1 is complementing. Q1 presently 1. 1 complement is 0. Next is complement of present. Again T0 is 1. Q0 is complementing. T0 is 1. Q0 is complementing. Q0 presently 0. Next will be complement of that. It is 1. Now 0, 1 becomes a present state. 0, 1 becomes a present state. Then based on this 0, 1 present state, what is inputs we are getting? Q0 bar. 1 bar is 0. T0 is 1. So when T1 is 0, Q1 remains same. When T0 is 1, Q0 will be complementing. 1 complement is 0. Right? So what we have here? 0, 0 to 1, 1, 2, 1, 0 to 0, 1, 2, 0, 0. Sequence. There will be 4 options. We have to choose one correct answer. Simple thing. Toggle flip-flop characteristics is T equal to 0. It is not toggling. That is not changing. It will be same. When T equals to 1, toggling means complementing. If it is 0, it becomes 1. If it is 1, it becomes 0. Simple way. So based on the present state, we are getting present inputs. How we are getting present inputs? From the counter circuit, we know expressions. We know expressions. Right. That's what we can understand. Counter analysis. We do some more examples on counter analysis. Yes, Dinesh Sai, very good. Annapurni, very good. So you have been doing correctly. Most of you are doing correctly. So for today, let me stop here. Do you have any doubts? Just a minute. Just let me save this first. Yes. Nagalingeshwar Rao.
Good morning, sir.
Yes. Very good morning, Nagalingeshwar Rao. Tell me.
Sir, is any shortcut to find the sequence? Otherwise, we have to follow this procedure only.
You have to follow this procedure only.
No more shortcuts, sir.
If I use that shortcut, like here itself, I can say it is 0, 0. I'm getting these inputs and so and so. I can analyze the after experience.
Okay, sir.
Shortcuts is always with experience only, right?
Yes, sir.
So if I give my shortcut, if you are following the shortcut, if you are remembering only shortcut, then you may be doing a mistake. So
Okay,
let me
sir.
follow this. You can find your own shortcuts. Just it may not be taking more than 1 or 2 minutes, right?
Yes, sir.
Right? They won't give you that 4-bit counter or 5-bit counters. Don't worry.
Only
The
to.
big sequence may not be there, right?
Okay, sir.
No shortcuts. Sir. Don't follow any shortcuts.
Thank you, sir.
Morning, sir.
Yes, Manisha. Yes.
Sir.
Yes, Manisha, tell me.
Sir, yesterday you gave one question, sir.
Yes,
That
yes.
one.
I told you, right? 1 is wrong. 2 is correct.
Yes,
Whatever you
yes.
have said.
Sir,
I will discuss. I will discuss.
sir,
I will discuss in the class.
yes, sir.
Let me give you one hint. You don't need to implement T directly as D is available. D is already implemented, right? Perfectly, you have implemented D and D to T. D is nothing but T XOR Q. As perfect D flip flop is available with you, go with the D to T there. Instead of implementing AB to T, D to T, you will get easily. Manisha,
Yes, sir.
now you get right.
Yes, sir.
That will give correct answer. Yes. Any more?
Sir, sir,
I
one.
think your network is an issue, not audible correctly. Manisha.
Sir, now is it audible?
Yeah, tell me.
Sir, in gray code counter is there, na, sir? Gray counter.
Yes.
Sir, there normally you said a formula to convert a binary to gray, na, sir. Using that we can't do that one.
How can you design a counter, right?
No, sir.
Are you able to? Yeah, you can do that. By writing 0001 1011, go with the formulas we have given. Not a problem. Then also you'll be getting same, right? After 00, next is 01, next is 11, next is 10, again back to 00. Gray sequence.
Sir, in that normally we XOR, we take the first bit and then after we XOR the previous bit with that, na, sir. Like
Got
that,
it.
if we consider this is not same as like that one, sir.
Right. 00 binary, 01 binary, 10 binary, 11 binary. What we get here? 0, 0. Right? What we get here? 0 is same XOR of this 1. 1 is same XOR of these two. What we get?
1 1
And 1 is there XOR of these two. What we get?
1 0.
Then what is the problem? Have you tried?
Yes, sir, I tried, but the JK values which are there, na, sir, they are not same as it.
That is from excitation table of JK, right? That is
Yes.
from excitation table of JK.
Yeah, I took with the help of excitation table only, sir, but it's not as it you gave, sir.
Please take this where you have done a mistake. Please check. Please check.
Okay.
Right? Please check. Right? Any more doubts, Manisha?
No, sir.
Right. Thank you. Arpit.
Sir, I had a doubt that, sir, can we use JK flip-flop, T flip-flop like that together in a circuit to design counter?
Yeah.
Or
you
it is necessary
can-
to use only same type of flip-flop?
No. You can use any flip-flops. Already you are getting such questions also in the exam. One JK and T already given long back. There was a question by giving a counter. They asked what is sequence it is going to.
Okay, sir.
It is possible.
Yes, sir.
Means you need to know all the flip-flops tables correctly before going to
Yes.
exam. Yes. Any more doubts?
No, sir.
Prithviraj.
Hello, sir.
Yes, Prithviraj.
Sir, homework problem excitation table is doubt.
రావట్లేదు కదా రావట్లేదు
రావట్లేదు సార్.
రావట్లేదు నేను చెప్తాను క్లాస్ లో
Okay,
అంతవరకు
sir.
దాన్ని అలాగే మనసులో ఉంచు ఏదైనా ట్రై
Okay,
చేయి
sir.
సాధ్యమైతే
అదే, sir.
ట్రై చేయి నేను చేస్తాను
ఓకే
నేను
సార్.
చేస్తాను. రైట్ రైట్
థ్యాంక్ యూ.
ఇంకేమైనా డౌట్
అదొకటే సార్.
సరే ఓకే నేను చేస్తాను క్లాస్ లో చక్రవర్తి
Sir, last slide, sir.
ఓకే which number is that okay here
Yes. Sir, I just find it difficult to understand between what is the present state and present input, sir. Like, if in
present
this,
state we are assuming before occurs the clock and we have a state.
okay, sir.
So based on the present state only we need to provide the inputs.
Yes, sir.
When we know that present state and present input, can't we say what is the next state? Characteristics.
So, but like,
When I know
we
when
just
I know
need
what
the
is
present input,
see,
right,
see,
to
see.
get the next state. We don't.
Yeah,
need to-
next state we are getting because of present state and present input.
Because of present input only, no, sir. We just get the next state.
No, that is only for D flip flops, right?
Okay, okay, sir.
Here the Q of n plus 1 is depending on Q of n also. You need to observe Q of n also. The Q of n is what? Present.
Yes, sir.
That is the reason we need to look into present state also, not only present inputs.
Okay, sir.
If it is D flip flops, sir, it is purely depending on inputs. It is not at all depending on Q of n. Whatever we are giving on D will be the next state.
Okay, sir. Thank you.
Done?
Yes, sir.
Right, thank you. Yugasri.
Sir, good morning, sir.
Very good morning, Yugasri.
Sir, మీరు నిన్న చెప్పారు కదా సార్ గ్రాఫ్స్
Tables, అమ్మా.
మాస్టర్ స్లేవ్స్ అది
ఓకే అది ఓపెన్ చేయాలి ఇప్పుడు.
సార్ దాంట్లో ఎలా అడుగుతారు సార్ క్వశ్చన్స్?
ఏమి అడగరమ్మా, అవి ఎప్పుడు కూడా బేసిక్స్ పనికొస్తాయి మనకు. అలా ఎప్పుడు క్వశ్చన్స్ అడగరు. వాటి మీద బేస్ చేసుకుని క్వశ్చన్స్ వస్తాయి. నేను నెక్స్ట్ చెప్తాను, నీకు అర్థమవుతుంది. నువ్వేమి కంగారు పడాల్సిన అవసరం లేదు వాటి గురించి. నేనైతే టర్మ్స్ చెప్పాను, ఆ టర్మ్స్ అర్థమైనా?
అంటే కొంచెం కన్ఫ్యూజ్ ఉంది సార్ ఇది.
మీనింగ్ అర్థమైందా? ఇన్పుట్ ముందు స్టేబుల్ అయి ఉండాలి, తర్వాత కూడా స్టేబుల్ ఉండాలి. ఇవి అర్థమైనాయి కదా. ఫ్లిప్ ఫ్లాప్ డిలే ఉంటుంది. ఫ్లిప్ ఫ్లాప్ కూడా 0 టైంలో ఎడ్జ్ దగ్గరే చేంజ్ అవ్వదు. ఎడ్జ్ తర్వాత కొంచెం టైం పడుతుంది అవుట్పుట్ చేంజ్ అవడానికి. ఇవన్నీ అర్థమైనాయి కదా. ఇవి పాయింట్స్ చాలమ్మా. నెక్స్ట్ అర్థమవుతుంది ఎక్కడ యూజ్ చేస్తుంది ఇవన్నీ. తొందర ఏం లేదు, అన్ని అర్థమవుతాయి. కొంచెం టైం తీసుకుందాం, సరేనా? ఇంకేమైనా డౌట్ ఉన్నాయా?
మీరు నిన్న ఇచ్చిన హోంవర్క్ ప్రాబ్లమ్
నేను చెప్తాను క్లాస్ లో, నేను చెప్తాను. అంతవరకు అలాగే క్యారీ చేస్తున్నాడు. ఏదో ట్రై చేయండి, ఏదో ఒకటి. కొంతమంది చేశారు, కొంతమంది వాట్సాప్ కూడా చేశారు ఆల్రెడీ, కొంతమంది ట్రై చేశారు. అంటే చేస్తే మనకి బాగుంటుంది, అంటే ఒక కాన్ఫిడెన్స్ వస్తుంది. అందుకని నేను చెప్పట్లేదు, ఇప్పుడే చెప్తాను. కొన్ని రోజుల తర్వాత 1-2 days తర్వాత నేను మళ్ళీ చెప్తాను, అదే క్వశ్చన్ చెప్తాను. ఇంకేమైనా డౌటా?
ఏం లేదు సార్.
ఓకే, ఎస్ మా, ఎస్ అన్మ్యూట్. ఎస్ యుగశ్రీ
సార్
చెప్పమ్మా.
ఇక్కడ క్యూబ్ బార్ ఇచ్చారు కదా సార్, లాస్ట్
ఇక్కడ
సార్
బార్
మనకు వచ్చింది కదా సార్ ఇది క్వశ్చన్
ఇదా?
సార్ ఇది
Q1 బార్ ఇచ్చారు.
Q1 బార్ Q1 డాట్ Q0 ఇచ్చారు సార్. Q1 బార్ 0 కాంప్లిమెంట్ కాంప్లిమెంట్ కి తీసుకున్నాం కదా సార్, మళ్ళీ ఇక్కడ
జీరో కాంప్లిమెంట్ ఇస్ 1.
జీరో కి జీరో ఎలా వచ్చింది సార్? నాకు అర్థం కాలేదు ఇక్కడ. Q1
ఇక్కడ
X0.
ఇప్పుడు 0 ఇనిషియల్ స్టేట్ అనుకున్నాము, స్టార్ట్ చేసాము. వీటి మీద ఇన్పుట్స్ ఏమొచ్చాయి? Q1 బార్ అంటే 0 బార్ అంటే 1 కదా.
Yes, sir.
ఈ ప్రజెంట్ స్టేట్ మీద డిపెండ్ అయ్యి ఇన్పుట్స్ వస్తున్నాయి. Q1 బార్ 0 బార్ 1 కదా. Q1 XNOR Q0 అంటే ఏం రాస్తుంది? 0 XNOR 0 ఏంటి? అయ్యో, 2 ఇన్పుట్స్ సేమ్ అంటే XNOR ఏమొస్తుంది? 2 ఇన్పుట్ XNOR అవుట్పుట్ 1 అవుతుంది. XNOR అమ్మా.
Okay, sir.
0 XNOR 0 ఏమవుతుంది? 1 అవుతుంది కదా.
Okay.
XNOR గేట్ ఫంక్షనాలిటీ ఏంటి? 0 0 0 1 1 0 1 1 కి 1 0 0 1 2 ఇన్పుట్ XNOR అవుట్పుట్ ఇస్ 1 when 2 inputs are same. ఇక్కడ సేమ్ ఉన్నాయి కదా.
Okay.
అర్థమైంది కదా. ఇంకా
అంతే సార్.
ఓకే. వెంకన్న,
Sir, good morning, sir.
వెరీ గుడ్ మార్నింగ్ వెంకన్న.
Can you audible, sir?
ఐఎమ్ వెరీ మచ్
Sir.
audible. Tell me.
Okay, where we use flip-flops, sir, in application purpose.
Everywhere we use flip flop only.
అంటే ఎలా అర్థం కావట్లేదు.
దాని ప్రాబ్లం ఏంటనేది రేస్ అరౌండ్ చెప్తాను.
ఓకే.
లాచెస్ యూజ్ చేయడం వల్ల ఏమవుతుందంటే
Hmm.
నీకు అడిషనల్ గా ట్రిగ్గరింగ్ కి సర్క్యూట్ అనేది తీసుకోవాలి. ఏమంటారు? పల్స్ ట్రైన్ అంటారు, లేకపోతే స్మాల్ పల్స్ అంటారు, ఇవన్నీ ఉన్నాయి. ఆ ప్రాబ్లమ్స్ అన్ని ఉండకూడదు అంటే ఫ్లిప్ ఫ్లాప్ తీసుకో, ఎడ్డి ట్రిగ్గర్ అంతే. ఇంకా
ఓకే ఓకే సార్.
ఒక సైకిల్ ఒకటేసారి చేంజ్ అవ్వాలి, మళ్ళీ మళ్ళీ చేంజ్ అవుతే కష్టం. అర్థమైందా?
ఓకే సార్.
అని ఫ్లిప్ ఫ్లాప్ ప్రిఫర్ చేస్తూ చెప్తారు.
ఓకే, థ్యాంక్ యూ సార్.
ఇంకా
నెక్స్ట్ ఇవి సెటప్ టైం, హోల్డ్ టైం ఐ కెన్ అండర్స్టాండ్ సార్. ఐ కాంట్ అండర్స్టాండ్ దిస్.
నేను చెప్తాను.
Okay.
మళ్ళీ చెప్తాను, మళ్ళీ యూజ్ చేస్తాను, ఎందుకు ఉంటాయి కూడా చెప్తాను.
Okay.
ఈఆర్ఈసి
ఈ సార్, ట్రిపుల్ ఈ.
ఈ అయితే అంత
Electric.
టెక్స్ట్ ప్రాసెస్ అవసరం లేదు.
ఓకే సార్, దట్స్ వై ఐ కాంట్ అండర్స్టాండ్ సార్.
అవసరం కూడా లేదు. కరెక్ట్ చెప్పాలండి, అది కంబైన్ క్లాస్ కాబట్టి, ఈసీ ఇన్స్ట్రుమెంటేషన్ కాబట్టి నేను చెప్పాలి, తప్పదు.
ఓకే ఓకే సార్.
అంతగా అవసరం పడకపోవచ్చు, చెప్పలేదు.
Actually, we are very suffered with that, sir. So that's why I am asking.
Yeah, no problem.
Okay, thank you.
Pratik Pramod.
Hello, sir.
Yes, Pramod. Tell me.
Hello.
Yes, Pramod.
Sir. Modulus of. Please explain modulus of counter, sir.
Mod counter. Yes. What happened?
Meaning समझ में नहीं आया थोड़ा सर.
Meaning? यहाँ पे देखो कितना states ये काउंट कर रहे हैं. कितना states?
5.
1 2 3 5 नहीं, ठीक. Count
6.
हाँ. Mod 6.
Okay, sir. मैं
Number of, I have given right statement. The number of distinct states counter is repeating is called modulus of the counter.
Okay, sir.
If 5 states mod 5, it is 6 states, it is mod 6. That's it.
मैं 0 काउंट नहीं कर रहा सर. काउंट कर नहीं रहा था.
States, number of states है ना. 0 भी एक स्टेट है ना.
Okay, sir.
ठीक है. और बस
sir.
No doubt, sir.
హలో
Bhaskar.
హలో సార్.
Yes, tell me.
సార్, అది ఈ రోజు వేవ్ ఫార్మ్ చెప్పారు కదా సార్, ఇది కంట్రోల్ డి
అవును.
సార్. ఇక్కడ ఎగ్జాక్ట్ ఎడ్జ్ ట్రిగ్గరింగ్ దగ్గర ఇన్పుట్ చేంజ్ అయితే
ఎడ్జ్ దగ్గర ఇన్పుట్ చేంజ్ అవ్వకూడదు. ఎడ్జ్ కంటే ముందే చేంజ్ అవ్వాలి. ఏమైనా చేంజెస్ ఉంటే ఎడ్జ్ దగ్గర మాత్రము ఆ ముందు తర్వాత కొంత టైం మాత్రము ఇన్పుట్ చేంజ్ అవ్వకూడదు. చేంజ్ అయితే కనుక ఫ్లిప్ ఫ్లాప్ కి కన్ఫ్యూజన్ ఉంటుంది, సరిగా క్యాప్చర్ చేయలేదు. అందుకని క్లాక్ ఎడ్జ్ కంటే ముందే స్టేబుల్ అవ్వాలి. ఆ ఏదైతే క్యాప్చర్ చేయాలనుకున్నామో ఆ ఇన్పుట్ కూడా క్లాక్ ఎడ్జ్ తర్వాత ఇంకొంత టైం ఉండాలి.
సార్, ఒకవేళ కంట్రోల్ 1 to 0 వెళ్ళింది అనుకో సార్, అప్పుడు ఇన్పుట్ కూడా అక్కడ
1 to 0 వస్తే
అలా ఏముండదు, అలా ఏముండదు. ఏంటి ఇది క్లాక్ 0 నుంచి 1 పోతుందా, 1 నుంచి అది కాదు. క్లాక్ ఎడ్జ్
ఒకవేళ
దగ్గర,
ఒకవేళ
క్లాక్
అట్లా
ఎడ్జ్
కన్ఫ్యూజ్
దగ్గర లిజన్ సరే, క్లాక్ ఎడ్జ్ దగ్గర అది 0 to 1 చేంజ్ అవ్వచ్చు, 1 to 0 చేంజ్ అవ్వచ్చు. అది చేంజెస్ అవ్వకూడదు అంటుంది.
ఓకే ఓకే సార్.
రైట్, అసలు చేంజెస్ ఆ విండోలో అవ్వకూడదు అసలు. అయితే కనుక ఫ్లిప్ ఫ్లాప్ కన్ఫ్యూజన్ లో ఉంటుంది. అరే ఇన్పుట్ 0నా 1 అనే కన్ఫ్యూజన్ వస్తుంది.
అవును.
అర్థమైందా?
ఓకే సార్.
భాస్కర్,
ఓకే థ్యాంక్స్ సార్.
పరం,
Good morning, sir.
వెరీ గుడ్ మార్నింగ్ పరం.
Sir, the first slide we used while designing that, no, not this one, previous one, setup time and all.
Okay.
Sir, those are same from both counters and flip flops, sir.
Yeah, actually, functionally we are designing this. Whenever you are really observing whether it is working as not as expected or not, that will be depending on those parameters. That I'll discuss later. Why we need setup and hold also, I'll discuss.
Okay, so my doubt was the setup time and hold time are both means the parameters are expected in both flip flops and latches, sir.
Flip flops only, not latches.
Only flip flops. Okay, sir. Okay.
Only flip flops.
Okay, thank you, sir.
Thank you. Okay, then see you tomorrow. What happened, Param?
Nothing, sir, nothing.